In the vast expanse of the cosmos, where the fabric of reality shimmers with stars and galaxies, an unimaginable event unfolded, an explosion so powerful that it sent ripples through the very fabric of the universe itself. Imagine, for a moment, the raw intensity of a force that could not only vaporize entire worlds, but could also affect gravitational waves light years away. You might be wondering, what caused such an extraordinary cosmic eruption, and how did it shake the universe to its core? Welcome on this thrilling journey as we dive into the depths of space and time to uncover the secrets behind the cosmic explosion that transcended our understanding of the universe. From celestial fireworks to a modern scientific breakthrough, we're about to reveal insights that may just leave you astounded. Stay tuned, because what comes next will leave you speechless. An explosion, when we think of it in earthly terms, evokes images of fireworks on a summer night or the dramatic end of a skyscraper, controlled chaos within a contained environment. But in the realm of astronomy, explosions can be far more dramatic, and we are not talking about the work of humankind. Instead, we're gazing into the eyes of phenomena so magnificent and destructive that they defy the laws we believe govern our universe. In the early days of the universe, just after the Big Bang, energy and matter coalesced into the first stars, and the tapestry of galaxies began to weave itself through the cosmos. Fast forward billions of years. Light years away, supernovae were quietly waiting for their moment to unleash fury. When massive stars reach the end of their lives, they can no longer sustain their own gravity, which leads to a spectacular collapse until all that energy explodes outward. Within seconds, these forces of nature release more energy than our sun will produce across its entire lifespan. However, not all explosions are born equally. Have you ever wondered what drives this cosmic chaos? Surprisingly, many factors contribute, including the star's mass, composition, and even the environment it exists in. Picture matter swirling in a cosmic dance, a process that occurs on scales far beyond human comprehension. The energy released during these cataclysmic events reverberates across the universe, creating shockwaves that affect both space and time. What's even more incredible is that these events don't just occur in a vacuum, they can influence the very formation of new stars and even entire galaxies. Here's something you didn't expect. Scientists estimate that somewhere out there, every second, a star goes supernova. For a galaxy like ours, the Milky Way, we can expect to witness such an explosive demise roughly once every 50 years. But one particular explosion, known as SN 1998 BW, took everyone by surprise, not only for its scale but for the revelations it would bring to our understanding of the universe. The origin of SN 1998 BW was entwined with gamma-ray burst 980425, an event that occurred in the now infamous Galaxia de Fornax. When astronomers first observed the gamma rays from this explosion, they were on the brink of a phenomena that seemed to defy explanation. Gamma-ray bursts are intense flares of energy that emerge from cataclysmic stellar events, and they are considered some of the most powerful explosions in the universe. For centuries, the question lingered, are these bursts related to supernovae, or are they entirely separate enigmas? In the case of SN 1998 BW, the answer came as a revelation that shook the astronomical community. This wasn't just an ordinary supernova, it was associated with a gamma-ray burst, demonstrating for the first time a connection between these two cosmic phenomena. It was as if the universe had decided to wave a flag and declare, "Look here. There's more to the story." It was an intersection of two celestial events, and astronomers were suddenly confronted with a new understanding of how energy behaves in these explosive environments. But just how does an explosion so powerful send shockwaves through the very structure of the universe? The answer lies in the sheer amount of energy released during these colossal detonations. Think of it like this: when a supernova occurs, it releases enough energy to create elements heavier than iron. Gold, silver, lead, these precious materials are formed in these cataclysmic explosions, scattering across the universe and eventually becoming a part of planets, stars, and even us. That's right. The very atoms in your body were once forged in the hearts of dying stars, making you, with every breath you take, intimately connected to this cosmic drama. Isn't it both exhilarating and humbling to think that the universe operates on such monumental scales? But the excitement doesn't stop there. During these cosmic explosions, shockwaves are generated, traveling at incredible speeds and creating interactions that can be observed for millions of light years. These interactions can lead to the ignition of new star systems, further fueling the cycle of birth and death within galaxies. We often hear that everything in the universe is interconnected, yet it's mind-boggling to realize just how profound these chains of events are. As we dig deeper into the saga of cosmic explosions, let's remember another iconic event, the explosion of SN 1987A. Detected by scientists in 1987, this famed supernova shed light on yet another aspect of the cosmic chain reaction triggered by stellar death. It exploded in the Large Magellanic Cloud, a satellite galaxy of the Milky Way, and was one of the closest such events to Earth in recent history. Over weeks, the brightness of SN 1987A fluctuated, thrilling astronomers around the globe as they collected data that would help unlock several of the universe's greatest mysteries. What's particularly fascinating about this explosion is its aftermath. The energy released was immense, but its lingering effects were even more captivating. Charged particles and radiation interacted with the surrounding gas clouds, creating new structures and elements in the universe. As we understand the aftermath better, it becomes clear that these explosions are not just endpoints, they're also potent catalysts for new beginnings. Pause here for a moment. Can you imagine a universe where such powerful events transpire every moment, reshaping the very essence of everything we know? The echoes of these cosmic explosions are present in the distant whispers of light reaching our telescopes, connecting us to events that occurred millions of years ago. When astronomers peer into the night sky, they're effectively looking back in time, witnessing the remnants of past cosmic power. Now let's pivot to a groundbreaking moment that will forever change how we perceive these astronomical events. In 2015, gravitational waves were detected for the first time, the ripples of spacetime which were theorized by Albert Einstein over a century earlier. This was not just a minor achievement, it was akin to handing scientists a new pair of glasses to see the universe in a way they'd never imagined. This discovery offered a novel tool to explore cosmic explosions by detecting their gravitational signatures, subtle but powerful reverberations resulting from events such as supernovae or merging neutron stars. You might be wondering, how do these gravitational waves relate to the cosmic explosions we've been discussing? These waves can potentially inform us about the dynamics of the event, helping researchers better understand how explosions propagate through space and time. Each new detection gives insights into the inner workings of stars and the forces at play during their demise. As we stand on the precipice of these astonishing revelations, a pivotal question arises: what happens next? With the advent of new telescopes, detectors, and a growing catalog of explosive events, scientists are constantly refining their theories and predictions about the universe. The process of scientific inquiry is never-ending, driven by an insatiable curiosity about the very nature of existence. Every new discovery is both an endpoint and a new beginning, sparking fresh questions that propel us further into the unknown. In our ongoing quest for knowledge, the explosion that shook the universe stands as a testament to the profound interconnectedness of all things. Imagine, each cosmic force, from the smallest supernova to the most massive black hole, contributes to a grand narrative spanning billions of years and encompassing unimaginable distances. What other secrets does the universe still hold, waiting to be unveiled by the relentless pursuit of understanding? Stay tuned, because in the second part of our exploration, we will delve even deeper into the implications of these cosmic explosions, the technology propelling our discoveries, and the mysteries that continue to baffle astronomers. We will uncover the latest theories about how these powerful events might shape not only our universe but also the potential trajectories of humanity's future explorations among the stars. Prepare yourself for the journey ahead, where the boundaries of our cosmic understanding will be pushed even further, and the revelations will unfold like the petals of an extraordinary flower blooming in the cosmos. The universe is alive, and the stories it has yet to tell are far more thrilling than we might ever imagine. So let's keep going, there's so much more to discover. As we embark on the second part of our cosmic journey, let us delve into the fascinating interplay of technology and exploration that fuels our understanding of supernovae and other astronomical phenomena. In an age where our dreams of interstellar travel seem both tantalizingly close and astonishingly distant, advancements in technology illuminate our path, revealing the intricate workings of the universe. One of the most groundbreaking tools in contemporary astronomy is the highly advanced array of space telescopes that scan the cosmos for signs of stellar death. Instruments like the Hubble Space Telescope have offered us unparalleled views of supernova remnants, seeking to unravel the threads of energetic events that sculpt our universe. The James Webb Space Telescope, launched in late 2021, has further revolutionized this quest. With its powerful infrared capabilities, it has the potential to detect the faintest signals from the earliest phases of the universe, allowing us to glimpse not just explosions but the galaxies that birthed them. What makes the James Webb particular is its ability to observe through cosmic dust. This is crucial, as many stellar explosions occur within dense clouds of gas and dust, shrouding them from traditional observations. With adaptive optics and instruments specifically designed to pioneer scientific discovery, the Webb empowers astronomers to capture the birth and death of stars across cosmic time, laying the groundwork for a profound understanding of how stars influence their surroundings. Think of each new observation as a slice of bread in the baking of a universe-sized loaf. Together they form a narrative that extends beyond our own galactic neighborhood. By tracking the echoes of past explosions in different wavelengths, astronomers can map the paths of the energy, uncovering patterns that were previously obscured. What once seemed chaotic and incomprehensible now unfolds before our eyes, revealing intricate designs dictated by the fundamental forces governing the cosmos. As we look closer at supernovae and gamma-ray bursts, let's explore the extraordinary advances in astrophysical modeling made possible by computational power. Simulations that once took days to run can now be completed in mere minutes, due to skyrocketing processing abilities. These models allow scientists to accurately simulate the interplay between energy releases and matter under extreme conditions, examining various scenarios involving stellar collapse and explosion. Not only do they help us visualize how an explosion unfolds, but they also provide critical insights into the distribution of heavy elements, that gold we mentioned earlier, throughout the galaxy. One of the most exciting outcomes of the merger of computational modeling and real-time observation is the dramatic revelations around neutron star mergers. When two neutron stars, a remnant of a supernova, collide, they create gravitational waves that ripple through space and unleash torrents of gamma rays and heavy elements. For those keepers of cosmic secrets, events such as the merger of GW 170817 in 2017 marked a significant milestone. This event was groundbreaking, not merely for the gravitational waves detected but because it was simultaneously observed across numerous wavelengths, from gamma rays to optical and even infrared. Imagine the race among observatories worldwide as they scrambled to observe this fleeting moment in time. Astronomers confirmed that this explosion resulted in the creation of kilonova, bright emissions resulting from the rapid nucleosynthesis of heavy elements. In real time, the impacts of such mergers revealed the profound interconnection between largely independent phenomena. What was once a discrete stellar explosion was now seen as part of a grander narrative on cosmic recycling and the formation of elements that adorn our jewelry and populate our Earth. As we draw nearer to the implications of these discoveries, it's essential to contemplate how supernovae and their associated events stretch the boundaries of our comprehension of the universe and our place within it. The narratives formed around these explosions challenge our understanding of the cosmos and invite us to query deeper philosophical questions. What is our cosmic significance if the very elements that sustain life have roots buried in the ruins of stars? One implication is the principle of recycling within the universe. The cycle of stellar birth, death, and rebirth underscores the interconnectedness of all existence. This celestial narrative permeates various civilizations' understanding of the universe, weaving cultural threads that resonate far beyond scientific inquiry. Despite the monumental strides made, significant questions persist. Why do some stars explode as supernovae while others collapse into black holes? What role do magnetic fields and rotation play in shaping the dynamics of these explosive events? Future generations of astronomers and physicists, armed with burgeoning technologies, will continue to unravel these mysteries. Every discovery could further challenge our preconceived notions of cosmic behavior. Turning our gaze inevitably leads us to the philosophical ramifications of our newfound knowledge. As consciousness expands into the cosmos, who are we amidst the grand tapestry of the universe? Are we mere observers, or do we play a role beyond our comprehension? The duality of our existence emerges as both insignificant in the vastness and profoundly connected to every detail of the cosmos, as we are made from the very atoms forged in stellar explosions. Perhaps one of the pivotal questions that arise from these explorations is how can humanity harness this cosmic understanding? As our world faces challenges, climate change, resource scarcity, and the quest for sustainable energy, could the lessons learned from the universe's cycles guide us toward solutions? The interconnected nature of stellar explosions could inspire innovations that reshape our relationship with the Earth. The energy released in supernovae isn't merely destructive, it is transformative, the raw materials for potential futures. In pondering our cosmic lineage, perhaps we can forge a more sustainable path forward, understanding that we too are part of a much larger cycle of cosmological death and rebirth. Just as stars give birth to new worlds, our actions can lay down the framework for future generations. This cosmic insight also emphasizes exploration's role in humanity's narrative. Field missions, like those proposed to visit asteroids or the Moon, provide Earth in transit with renewed energy and perspectives. For every star we explore, for every piece of knowledge gained from missions such as the Mars rover or the study of solar flares, we tether ourselves closer to those ancient cosmic fires that forged heavier elements, driven by an eternal curiosity. The intersection of exploration and discovery leads us to the intriguing possibility of extraterrestrial life. As we look beyond our own solar system, could the debris from supernovae harbor the necessary ingredients for life on distant planets? Just as our own solar system formed from the remnants of ancient stellar explosions, who can say what hidden secrets reside in the ashes of other celestial events? As we reach the conclusion of our cosmic exploration, we stand humbled by the enormity of the universe and its brutal beauty. The echoes of supernovae resonate across time, shaping the very building blocks of existence while initiating new cosmic epochs. Our journey through this study has shown that explosions and collisions extend beyond mere destruction. They reveal the symbiotic nature of creation and annihilation. In this vast cosmic theater, we leave knowing that not only do we have the privilege to observe, but we also play a role within this grand narrative. With every question posed and every mystery unraveled, we take another step toward understanding the fabric of reality and our place within it. In this endless inquiry, let us remember that our pursuit of knowledge extends beyond the mere cataloging of facts. It is fueled by a passion for understanding, a desire to connect with the universe itself. As we venture into the stars and explore the uncharted territories of knowledge, the burning question remains: what will we uncover next? So let us embrace the excitement that lies ahead, for each new cosmic event holds the keys to uncovering something greater than ourselves. The universe, with its shimmering stars and relentless transformations, is alive, and the stories waiting to be told are as boundless as the cosmos itself. We are but stardust, forever intertwined in the magnificent dance of existence, a cosmic saga that invites us all to join the journey.